Hello everyone, in this video we are going to solve the question number 2 of exercise 8.2. So let's read the question and get started. ABCD is a rhombus, PQR is the midpoint, okay, of side ABCD respectively, okay. Show that coital PQRS is a right angle. Okay, it's pretty easy question, we can solve it. Let's make the figure first and let me draw the figure. Okay, the rhombus, let's see, and we have to complete the construction first. Okay, and I just want to change the color so that you can see. Now we already made the figure, let's name it with a different color. So our rectangle is PQRS. Okay, PQRS, and the rhombus is ABCD. ठीक है, is there any other point? Okay, now what we have to do, basically we are going to apply the same midpoint theorem concept in this question. The what we have done in the previous video. Let's get started. Okay, so first we are going to consider triangle ABC. Okay, we are going to consider this triangle. Okay, and we are going to apply in this midpoint theorem. Okay, MPT, midpoint theorem. So as you can see, P is a midpoint. It is already given the question na. PQR is a midpoint of respective sides. We can say that. Okay, I'm not going to name it. And P is a midpoint of AB. Okay, given hai. And Q is the midpoint of side BC. Okay, so from the midpoint theorem, by applying midpoint theorem, we can say that PQ is parallel to AC. Okay, and also PQ is equal to half of AC. Just name it as 1. And similarly in triangle A, what is D? ACD, we can also write SR parallel to AC and SR is equal to half of AC. Name it as second. So we have combined all these things. Now let's separate them. Mark it here 1, and its PQ is equal to half of it is 2, and this one is 3, and mark this one it as 4. Okay, so that we can easily use it. Just avoid the confusion, just for avoiding confusion, nothing else. From 1 and 2, what we can say that? From 1 and 2, we can say that PQ is parallel to side SR from 1 and 2. From 1 and 2, how we can say that these are parallel? Because PQ is parallel to AC and SR is also parallel to AC. So the PQ is ultimately parallel to SR, because these both parallel to same line AC. Okay, and now what we have to do, basically from equation, from equation 3rd and 4th, what we can say that from equation 3rd and equation 4, we can say that PQ is equal to SR, because we have written, just because of with the use of midpoint theorem, PQ is equal to half of AC, and this one SR is also equal to half of AC, so they are both equal. Okay, so PQ is equal to SR. Now as soon as you realize the PQ and SR parallel and equal to each other, we can say that PQRS is a parallelogram. PQRS is a parallel chain. Now the first point is already we have shown that PQ is a parallelogram, and now we have to prove it like it is a rectangle. It is not only a parallelogram, it is also a rectangle. So for this, what we have to do is we have to like shift the figure first so that we can use it again. So what we have to do basically here, consider पहले तो first of all name it. Okay, let name it L, M, and these are the point which we are going to use. So in triangle BCD, consider triangle BCD. Okay, consider triangle BCD. So in triangle BCD we are again going to apply this midpoint theorem. So what we can say, since Q is the midpoint of BC and R is the midpoint of CD, not P. Okay, so we can say that just because of these two things, QR is parallel to BD, okay, by midpoint theorem. Okay, the second one we can say that QR is parallel to BD. Okay, so line, this implies that line QN parallel to LN. Name it as fifth, and we can also say that LQ parallel to MN. LQ, where is LQ? LQ is parallel to MN. Na, we have just proved it na earlier. Just because of midpoint theorem, we can say that since PQ also parallel to AC and QN also parallel to LM, na, so these are equal. Then only if they are parallel, na, so then we can say that these are equal also. Just because if the QR is parallel to BD, then also we can say that QN is parallel to LM. Na, we have previously proved that PQ is parallel to AC. Na, so its half is also parallel. So by saying this, we can name it as fifth. Okay. From fifth and sixth, we can say that since these are parallel to each other, so LM and Q is a parallelogram. We have proved it. LM and Q is a parallelogram now, and we know that the opposite sides of a parallelogram are equal, since ABCD is a rhombus. Okay, so its diagonal bisect at 90. Okay, so if this angle is 90, then this angle also will be 90, just because LM and PQ is a parallelogram and opposite sides of parallelogram are equal. And so this we can say that a parallelogram whose one angle is at right angle, okay, a parallelogram whose one angle is right angle, okay, then it is a right angle, or it can be a square also, but here we have to prove it is right angle, just because if in parallelogram now one angle is 90 degree, then it's in parallelogram this opposite angle is also 90 degree na, because opposite angle are equal in parallelogram. If one is 90, all will be 90 and 90 each na, and this is a property of a right angle, and hence we have proved it. If you have any doubt, just replay the video. Thank you.